Good day, everybody. How we are doing? I believe we're great. Welcome to my channel once again. Today we'll be looking at miscellaneous calculations on stoichiometry. Remember, we've introduced the subject of stoichiometry before now on the mass-volume relationship. So if you know you haven't seen that video on mass-volume relationship in reactions, scroll through my channel and watch that video before watching this for better understanding. All right, without wasting time, the first question we have on the board says, using the above equation, what volume of carbon 4 oxide measured at STP is liberated when 53 grams of sodium carbonate is dissolved in hydrochloric acid? And then we are given the parameters needed. Whenever you're given a question like this in your external exams, in your WAEC exams or your JAMB exam, what do you do? What's the first thing to do? The first thing you should take note of is the species in this equation whose amounts are being referenced. What do I mean by that? Let's read the question carefully. Using the above equation, what volume, take note of the word volume, of carbon 4 oxide measured at STP. So carbon 4 oxide is one of those species whose amount is being referenced. So what I do, okay, I put a little dot here, so I'm focusing on this product here, carbon 4 oxide, measured at STP is liberated when 53 grams, this is another amount of what now? Sodium carbonate. So this is sodium carbonate. So the first step is to identify the two species mentioned in the question, just as I have done. After identifying them, what's the next step? The next step is to identify the quantity, the amount of each of those species is being expressed in terms of what? For example, carbon 4 oxide, the amount is being expressed in terms of volume, while sodium carbonate, the amount is being expressed in terms of mass. Now, whenever a species amount is being expressed in terms of mass, the first thing you should do is calculate the molar mass of that particular compound. That should be your first step. So I will need to calculate the molar mass of sodium carbonate because grams signifies mass. So we say molar mass of Na2CO3 would be equal to, molar mass simply means the addition of the atomic masses of each element in this compound. So sodium, the atomic mass was given to you to be 23, but you have two sodium here, so you say 2 times 23 plus the atomic mass of carbon is given there to be 12, then plus the atomic mass of oxygen is 16, but we have 3 of them, so I multiply by this. So if you punch your calculator, that should give you 106 grams per mole. So it means 1 mole of this compound has a mass of 106 grams. Once you've gotten this, then you state your stoichiometry. So for this, I have just 1 mole of Na2CO3. So because I have 1 here, just 1, I'm going to say from the equation, what do we have? We have 1 mole, and 1 mole of this will say the molar mass is this. So I'll say 1 times 106 grams of Na2CO3 produced. Now this is carbon 4 oxide, my second species. What's the number at the back, the coefficient, which is your mole ratio? The coefficient at the back there is also 1, so I would write 1 times. Remember, what was said about carbon 4 oxide is volume, and 1 mole of any gas at STP occupies a volume of 22.4 dm cube. So I'll say 22.4 dm cube of CO2. So that's what we have from the equation. So the question now said we should do what now? Where is the question again? It said using the equation above, what volume of carbon 4 oxide? So you simply put a second arrow. So the side of carbon 4 oxide we don't know. The volume of carbon 4 oxide we don't know. So you put a variable there, say X. What volume of carbon 4 oxide? is liberated when 53 grams of sodium carbonate. So for sodium carbonate, we were given 53 grams of Na2CO3. So I am taking the volume occupied by the volume of carbon dioxide produced when 53 grams of sodium carbonate reacts. I'm taking that volume to do what? X. Once you arrange your stoichiometry like this, the next thing you do is to cross multiply, and then you make X the subject of formula. So X would be equal to 53 would multiply all numbers there. So 53 would be multiplying 1 and also 22.4. Then X would be multiplying the numbers here. Always divide with whatever X would be multiplying. So I'm dividing with 1 times 106. So we have grams as our unit. So you punch that in your calculator and that gives you your answer quickly. We have 53 times 22.4 divided by 106. So that gives me 11.2. This is not meant to be grams. X is under dm cube, is volume. So this will be dm cube. So your answer becomes 11.2 dm cube, which corresponds to option what? Option A. All right. I know most persons would be wondering, what's the need of putting the 1? I'm putting it so that in the subsequent examples we do, if the number here is 2, you don't forget to also add that. So in this case, the 1 is pretty much useless, but we're trying to get a system we work with consistently. Hence, we did it like this. We go over to the second example now. Okay, now let's look at the second example, which says 20 centimeter cube of a 2.0 molar solution of ethanoic acid. First of all, pay attention. Whenever you see a line like this in a question, the volume of, then you see this capital letter M actually represents molar solution. Okay, whenever you see that, take a pause and then do what I want to do now first. But before then, let's write our equation of reaction. We are reacting what? Ethanoic acid was added to excess of this. Now, take note, whenever you see a calculation and the word excess is used, the stoichiometry of a reaction is not really being determined in most cases by your excess reactant. It means I wouldn't really bother that much about the information given about sodium hydroxide because its amount is in excess. So we focus more on our limiting reagents, which is what determines the stoichiometry of the reaction. So you write your equation of reactions. We have ethanoic acid reacting with sodium hydroxide, then giving us the product. We have sodium ethanoate and then water. This is a neutralization reaction. As a student preparing for external exam, there are some basic reactions that you should know. So when you come across a question like this where you are not given the equation, you wouldn't fumble, because once you don't have the equation, the information of the reaction, then there's nothing you can do as far as this problem is concerned. Of course, this is our balanced equation. So I said when you see a calculation like this, you deal with this part of the question first. 20 centimeter cube of a 2.0 molar solution of ethanoic acid. So this is volume. This number represents concentration. If you know you've not watched my video on concentration, try and watch that video and then you will understand better. So we have that in chemistry, concentration. Let's divide the board into 2. We have that concentration is equal to amount, which is N over volume in dm cube. So these are formula for concentration. So the concentration was given to us to be 2.0. So in place of concentration, I will simply say 2.0 is equal to my amount we don't know. We don't know the amount that was dissolved in that solution. Then divided by the volume is 20. Divided by 20. So by the time you cross multiply, not just 20, remember we said in dm cube. So if you watched my video, I'm going to divide this by 1000 to convert to DMQ. So we have 2.0 is equal to what? N over, that should be 0.02. So by the time you cross multiply, your N will be equal to 2.0 times 0.02 moles. Why is the unit mole? Because when you see capital letter M, it actually means molar concentration. So it means amount is expressed in moles. So N would be equal to, that should give you 0.04 moles. So this is your first step. Calculate the mole of ethanoic acid that actually reacted. Now, after calculating your mole now, you can now state your what? Your stoichiometry. Now the question says 20 centimeter cube of that solution was added to excess of this. The mass of salt produced, mass of what? Salt produced. So what's the salt produced in this case? This is your salt. So we're stating our stoichiometry between this and this. Remember, that's your first step when solving calculation. So I'm using this and this. I told you, you don't bother about the sodium hydroxide because the amount is in excess. So we're stating our stoichiometry. What was mentioned about this is mass. So the quantity of this is being expressed in mass. And I told you, whenever a particular species, the amount is expressed in mass, you must calculate the molar mass of that particular species. So we'll calculate the molar mass. So molar mass of CH3COONA would be equal to, we have 2 carbons here. For us not to waste time, I will say 2 times 12 added to, we have 2 oxygens. Okay, we have a total of 3 hydrogens here. So I'll say 3 times 1. The values are given here. You just substitute. We have 2 oxygens here. So I can just say 2 times 16. Then we have sodium, which is 23. So we punch our calculator. So that's 24 times 3. 24 times 3 times 32. Oh, I'm multiplying. That's 24 plus 3 plus 32 plus 23. So that's giving us 82. 24. So that's giving me 82 grams per mole. If you wouldn't want to do that, you just press them individually. Carbon is 12 plus 3 plus 12 again plus 16 plus 16, then plus 23. So it still gives you 82. So after calculating the molar mass, you can now state your stoichiometry. You say from the equation, yes. So what's the number at the back? 1. That's the mole ratio, 1. So we have 1 mole of CH3COOH produces, why am I using mole? Remember, from my calculation, my amount here was mole. So I'm relating mole to what now? To mass. So 1 mole of this is producing what? Let's go to the mass. We have 1 here, so we say 1 times. What's the mass of this? We've calculated to be 82 grams of what? CH3 COONA. So we now got our mole that reacted to be this. So we say 0.04 moles of CH3COOH would give us what now? X. So at the end of the day, when you make X the subject of formula, X is going to be what? I told you to cross multiply. So if we cross multiply, X times 1 is X. Then we have 0.04 multiplying these numbers here, which is 1 and 82 grams. So you punch your calculator now. That's 0.04 times 82. So that gives me 3.28 grams. And that corresponds to option what? Option C. So that's how you tackle a problem like this. We move on to the next example quickly. Okay, now let's look at this problem together. They said 10 dm cube of air containing hydrogen sulfide as an impurity. So hydrogen sulfide was an impurity inside 10 dm cube of air. Okay, was passed through a solution of lead triazonitrate 5 until all the hydrogen sulfide had reacted. The precipitate of lead sulfide was found to weigh that. So lead sulfide said to weigh this. So I dot this part because the amount of lead sulfide was given. And then, of course, the question is centered around hydrogen what? Sulfide. Okay. So the question is what? The percentage by volume of hydrogen sulfide in the air is dash. Now remember that air is a mixture of gases. So air contains oxygen, nitrogen, the rare gases, vapors, and so on and so forth. So hydrogen sulfide happen to be one of the what? The impurities in the air. So what you simply do in a problem like this in your exam is to what? State your stoichiometry between these two. This was given in terms of mass. Remember, anytime they give you in terms of mass, you have to look for the molar mass of that species. So your first step is to get the molar mass. So molar mass of lead sulfide would be equal to, the atomic mass of lead was given to be 207 plus, the atomic mass of sulfur was given to be 23. So we'll punch that in our calculator, 207 plus 23, that gives us 230 grams per mole. All right, so since we've gotten the molar mass now, we can state our stoichiometry now. What we're interested in about hydrogen sulfide is what? Volume. Remember, the question said the percentage by volume of hydrogen sulfide. So I'm using volume here. And remember, 1 mole of a gas occupies 22.4 dm cube. So what do I say? I simply say from the equation, yes, from the equation we have the coefficient at the back here is 1. So 1 times hydrogen sulfide, the volume is 22.4 dm cube of hydrogen sulfide produced. We have 1 as the coefficient here also, which is 1 times the molar mass of PBS is 230 grams of PBS. So I'm interested in now knowing, remember that your next step is to put a second arrow. One side we have X. So which side we have X? Of course, the side of what? Hydrogen sulfide. So I'm interested in knowing the volume of hydrogen sulfide that is actually producing this particular mass of the precipitate. And the mass given for the lead sulfide now is 5.02 grams of lead sulfide. So once you make this arrangement, you already know what to do next. X goes to multiply this, and then this goes here. So at the end of the day, X would be equal to, if we cross multiply, we're going to be having this number multiplying this. So we have 1 times 22.4 times 5.02. Then remember, you are always dividing with that number that X is multiplying. So I divide with 1 times 230. So this would carry dm cube since X is the volume of hydrogen sulfide. So you punch your calculator to get the answer there. So 1 times 22.4 times 5.02 divided by 230. So that gives you 0.4889 dm cube. So this is the volume of what? The hydrogen sulfide that was present in the 10 dm cube of what? Air. So we now come down and say percentage of hydrogen sulfide in air will be equal to the volume of the hydrogen sulfide now divided by the total volume of air now, which is 10, then you multiply by 100%. So when you punch that, you arrive at your final answer. So we have 0.4889 times 100, then divided by 10. So that gives me 4.889%, which is approximately 4.9%. So that corresponds to what option here? Option C. So that's how you tackle problems regarding what? Impurity and percentage composition. We go over to the next question. All right, now let's look at this question together. It says 30 centimeter cube of 0.1 molar solution of aluminum triazonitrate 5. Solution is reacted with 100 centimeter cube of 0.15 molar solution of sodium hydroxide solution. Which reactant is in excess? So this question is asking us to calculate for the excess reactant. Please give me thank you. All right. So if we are looking for a reactant that is in excess, the first thing for you to do is to write your equation for reaction. Equation of reaction. So we have what's reacting: aluminum triazonitrate 5 reacting with sodium hydroxide. This is actually a displacement reaction where sodium displaces aluminum and aluminum takes the place of sodium. So aluminum will be bonded with the hydroxide. So you have AlOH3, and then sodium takes the place of aluminum. So you have NaNO3. So to balance the equation, I think we place a 3 here, and then we should place a 3 here. I think our equation is balanced now. Now, after balancing your equation, remember I told you whenever you come across this line in a stoichiometry problem, you make use of your formula for concentration. So we say what? Concentration is equal to what? Amount over volume in TM cube, remember. So for your aluminum, let's divide this board into 2. So for AlNO3, right? We have that what? The concentration is 0.1 mole per dm cube. So we say 0.1 is equal to N over, the volume is 30 centimeter cube, but we are converting. So you say 30 divided by 1000. Remember. So that gives you 0.1 is equal to N over 0.03. So if you cross multiply, your N becomes 0.1 times 0.03, which is 0.003 moles. So you've calculated the moles for this. You've done the same thing for your sodium hydroxide. So I'll come down and say for sodium hydroxide, so for sodium hydroxide, what I'm going to have, our concentration for sodium hydroxide is 0.15. So it says 0.15 will be equal to the amount all divided by the volume is 100 cm cube. So you divide 100 by 1000. So we can say 0.15 is equal to N over 0.1 if you divide this. So from there, if you cross multiply, N is going to be what now? N is going to be 0.15 times 0.1, which gives you 0.015 mole. So once you've gotten this now, the next thing you do now is to write, we'll take just this part of the equation, just for understanding. So we have AlNO3 reacting with 3 moles of sodium hydroxide. Now, the mole ratio here is, your mole ratio here is 1:3. So it means for every 1 mole of aluminum triazonitrate 5 that reacts, we have 3 moles of sodium hydroxide reacting. So the amount of sodium hydroxide that reacts is always 3 times this. But then we have discovered from our calculation that we made use of this mole of aluminum triazonitrate 5 and this mole of sodium hydroxide. So I'm going to write that as a mole before reaction. Mole before reaction. So your mole before reaction for this compound, we got 0.003. 0.003 mole. Then for this, we got 0.015 mole. Now, the next you do, you write reacting amount or reacting mole will be equal to what now? Now, if you look at the mole ratio, you will discover that if you want to know your limiting reagent, this is how you know your limiting reagent. At this stage, simply press this number divided by 1. Of course, it will give you this number. Then also press this number divided by this 3. If you press 0.015 divided by 3, I will have 0.005, which is bigger than this number. So the higher number you get represents your excess reactant. I repeat, when you divide this, your mole before reaction by the mole ratios, okay, the lowest result tells you which of your reactant is the limiting reactant. This is your limiting reactant now. The higher result, which is for this now, will tell you the one that is in excess. So your reacting amount, you always put down the mole for your limiting reactant, which is this. So we'll say 0.003 mole. So remember, for every 1 mole, we have 3 mole of this. So it means the amount of sodium hydroxide that reacts always 3 times whatever is reacting here. So I have to multiply this number by 3. So I'll say 0.003 multiplied by 3. That gives me 0.009 moles. Okay. Now, I'll write amount after reaction. Of course, your limiting reagent will be used up. So we have nothing left here. This minus this is 0. Then for this, you press this minus this, you get the amount that is left, 0.015 minus 0.009. So that would give you 0.006 moles. So it means the reactant that is in excess, of course, is sodium hydroxide. Then they said by how much? I've gotten it to be what? 0.006 moles. But the options are not expressed in moles. The options are expressed in what? In terms of volume. So what do I do? Okay, I'm going to take off this part of the board quickly. All right, now we've taken this part of the board off. What do we do next? Since the options are given in volumes, I go back to my formula that says what? Concentration is equal to amount over what now? Over volume in dm cube, remember. So if we substitute, the concentration of sodium hydroxide remains 0.15. So we'll say 0.15 is equal to the amount we are trying to convert now to volume is what? 0.06. So 0.06 over, I'm trying to know the volume. So if you cross multiply and you make V the subject of formula, V is going to be 0.06 divided by 0.15 dm cube. So our volume becomes, you punch your calculator, 0.006. I think there's a 0 here. There's an additional 0, as you can see over here. So 0.006, 0.006 divided by 0.15. So that gives me 0.04 dm cube. Again, our options are not in dm cube, rather in cm cube. What do I do now? To convert dm cube to cm cube, you multiply by 1000. So my V becomes 0.04 times 1000 cm cube. That should give you 40 centimeter cube. So it means that sodium hydroxide is in excess by 40 centimeter cubed. So that gives you option C. So this is the end of this problem. We move on to example 5. Okay. Now, we have that 10 centimeter cube of CO is mixed and packed with 100 centimeter cube of air containing 21% of oxygen. Let's pause there first. The word here is what? Air. So remember that air is a mixture of gases. If carbon 2 oxide is to react, which is carbon monoxide, is to react to air with air, the only component of air that actually reacts with is what? Oxygen. But then we are not given the volume of oxygen, rather we are given the total volume of the air, which is a mixture of gases that contains both nitrogen, the rare gases, and what have you. So what do you do firstly? We need to calculate the volume of oxygen that is actually inside this 100 centimeter cube. But before then, let's write our equation of reaction. So we are reacting what? Carbon 2 oxide gas with air. But remember, the component in the air that it reacts with is just oxygen. So you say plus O2 gas. And the product of this reaction, of course, is carbon 4 oxide, which is a gas. Then you confirm if your equation is balanced. I don't think so. So if you place a 2 here and place a 2 here, I believe our equation become balanced. Okay. So before we can make use of this equation effectively, what I would need to do, I will quickly do that by the side here. I will need to calculate the volume of oxygen in the air. So I'll come here and say volume of O2 is going to be what? It's going to be 21%, according to the question, which is 21% of out of a total volume of what? 100 centimeter cube. So that becomes 21 over 100 multiplying 100 centimeter cube. So 200 can cancel 100, so we have just 21 centimeter cube. So if they give you a question like this, you first of all calculate the volume of oxygen. Now, after getting the volume of oxygen, you will need to now get the volume of nitrogen, and essentially your rare gases, which will be equal to what now? 100 centimeter cube minus 21 centimeter cube, which gives you, I think, what now? 79, right? 79 centimeter cube. All right. So let me have my calculator. So if that is what we have, we can now go on. This is just by the way, you go on with your question now. So the first thing you're going to write is your volume ratio. Your volume ratio is equivalent to the number of moles of each of these reactants. So the number here is 1, the number here is 1, the number here is 2 rather, this is 1, and then this is 2. This is the volume ratio with which they combine. It means the volume of oxygen that always combines with carbon monoxide is always what? Half of the volume of carbon monoxide. So if you have 100 here, here should be 50. That is what this tells us. So after volume ratio, you're going to write volume before reaction. Volume before reaction. Volume before reaction simply means what was the volume that you brought for this process, for this reaction? What volume was brought? So according to the question, we actually brought 10 centimeter cube. So we have 10 centimeter cube. Then what was the volume of oxygen brought? That's what we've calculated. So be 21 centimeter cube. Then before reaction, you have no product, so you put a dash there. Thereafter, you write your reacting volume, talking about the volume that would actually react. Okay, So in this stage now, you need to know what your limiting reagent is and what your excess reagent is. How would you know that? Simply divide this by this. 10 divided by 2 is 5. 21 divided by 1 is 21. The lowest answer gives you the what? The limiting reagent. So this is my limiting reagent. That simply tells you that you should bring down this number. So this gives you 10 centimeter cube. So remember, whatever volume that should react here should be half of this volume. So if 10 centimeter cube is reacting, I should have just 5 centimeter cube of oxygen reacting with 10 centimeter cube. And then if the ratio of this to this is 2 to 2, it means if I have 10 centimeter cube there, you should also have 10 centimeter cube on this part. Then your last step is to write your volume after the reaction. So for you to get your volume after reaction, of course, nothing is left here. You brought 10 cm cube, 10 cm cube reacted, so nothing is left here. Then for this, 21 minus 5, you have a total of 21 minus 5, you have 16 centimeter cube of O2 left. And of course, at the end of the day, I have 10 centimeter cube of CO2 produced. So the question said you should do what? Calculate the volume of the resulting gases. So you say, therefore, volume of your resulting gases will be equal to, we have a volume left here, so we have 16. Added to, we have a volume left here, 10. And then we have 79 cm cube of the other components of air that did not react. So remember, air is a mixture, like we said. So only oxygen reacted. We still had these volumes of nitrogen, the rare gases, and other components of air amounting to 79 centimeter cube. So you also add this number. It's among your resulting gases left. So when you punch that in your calculator, you have 16 added to 10 added to 79. So that gives you 105 centimeter cube, which corresponds to option C over here. So this is the solution to this problem. We'll move on to the next question quickly. Okay, now let's look at the sixth example. Phosphorus burns in oxygen according to this equation. So how many liters of oxygen, so you dot oxygen, will be required at STP for the complete oxidation of 12.4 grams of phosphorus? So you dot phosphorus. So the amount, oxygen's amount is being expressed in terms of volume, while phosphorus amount is being expressed in terms of grams, which is mass. So I told you when the amount is expressed in mass, you must calculate the molar mass of that particular substance. So I'll come down and say molar mass of phosphorus would be equal to 4 times the atomic mass of phosphorus, which is 31. So that gives us 124 grams per mole. So after calculating that, the next thing you do now is to write your stoichiometry. So you say from the equation, we have 1, the molar coefficient here is 1, you write it 1 times the mass of phosphorus, the molar mass is what now? 124 grams of phosphorus is needed to react with 5. The molar coefficient, you must write it, times, remember what oxygen is expressed in terms of volume, and the volume for 1 mole of oxygen is 22.4 liters. So 5 times 22.4 liters of oxygen. So your next step always is to draw a second arrow where you put your unknown variable. So they said how many liters of oxygen. So the side of oxygen is unknown to us. How many liters of oxygen, okay, will be required at STP for complete oxidation of what now? 12.4 grams. So the side of phosphorus is having 12.4 grams of phosphorus. So we're taking the volume occupied by 12.4 grams of phosphorus to be X, which the question requires from us. So from this step, as you know, you always cross multiply. X multiplies here, this number multiplies this. At the end of the day, when you make X alone, you're going to have that 12.4 would multiply all the numbers here. So you see 12.4 would multiply 5 and also 22.4. Then always remember that you divide with the number that X is multiplying. So I'm going to be dividing with the numbers X is multiplying are 1 and 124. So X is liters, the volume is in liters. So you punch your calculator and then you have your answer. So 12.4 times 5 times 22.4 divided by 124. So that gives us 11.2 liters, which correspond to what option? Okay, the options weren't specified in this case. You could check your JAMB past questions and then you get the correct answer. So this gives us the answer for this problem. So we go to example 7 now. All right, now let's look at example 7. It said, in the above reaction, how much zinc will be left undeserved if 2.00 gram of zinc is treated with 10 centimeter cube of 1.0 molar solution of tetraoxosulfate 6 acid. So I always tell you in your exam, whenever you see this line, 10 centimeter cube of 1 molar solution of whatever, start your calculation from that point using the formula that says what? Concentration, let's divide this. Concentration is equal to what? Amount over what? Volume in what? In dm cube. So you simply substitute for H2SO4, the concentration was given to be 1.0 equal to N over, your volume in this case is 10 cm cube. So you say 10 divided by 1000. So you have 1.0 is equal to N over, that should give you 0.01. So if you multiply, N is going to be 1.0 times 0.01. So we have 0.01 moles. So you must get the moles of H2SO4 before you continue with your calculation now. So we are drawing, this question said how much zinc, and then our options are expressed in grams. So we're concentrating on zinc and then H2SO4. So say from the equation, so we're expressing zinc in terms of mass. So the mass for zinc now is what? 65. So it says 65. What's the molar coefficient? Though it's not that important, but I'll put it because I'm following a system. So this is 1 multiplying what? The atomic mass of zinc is 65. So if here were to be 2, ensure to also put the 2. So 1 times 65 gram of zinc is reacting with what? 1 mole of H2SO4. Okay, just in case you're wondering why I am not expressing this in grams, because what I have calculated for H2SO4 here, SO4 here is what? In moles. So I express this as 1 mole of H2SO4. So I would ask myself, what would be the mass of zinc that would be producing this, that would be reacting with 0.01 moles of H2SO4. So if you should cross multiply and you make X alone, X times 1 at the end of the day will be X would be equal to, these numbers will multiply this. So you have 1 times 65 multiplying this number here, 0.01 grams. So you therefore have 65. So you punch your calculator, 65 times 0.01. So that gives me 0.65 grams. Now, many students would pick D as the answer. JAMB is very tricky. Now, you need to understand the question. The question says what? How much zinc will be left undissolved if you actually react 2.0 gram of zinc? We have discovered that in this reaction, we just need 0.65 grams of zinc to react. This represents the amount of zinc that is needed to perform the reaction. But then we supplied a total of what? 2 grams of zinc. So we have excess of zinc. That's what it means. So we simply say, therefore, mass of zinc left unreacted will simply be equal to the mass you supplied minus the mass that actually reacted. So you punch your calculator and that gives you your final answer. So we have 2 minus 0.65. So that gives you 1.35 grams. So that becomes the solution to this particular problem. We move on to the last example for this video not to be too long. If you have any more question on this topic, you're free to drop it in the comment section. Okay, now let's look at this 8th example. Using 50 centimeter cube of 1 molar solution of potassium hydroxide and 100 centimeter cube of 1 molar solution of tetraisosulfate 6 acid, calculate the respective volumes in cm cube of base and acid that would be required to produce the maximum amount of potassium. Okay, of potassium tetraisosulfate 6. First of all, let's write the equation of reaction. So, equation of reaction. As a student preparing for JAMB and WAEC, please practice how to write, know some basic rules for reactions. Because calculations like this, once you don't even know your equation of reaction, there's nothing you can do about this question. So we are reacting potassium hydroxide. Let's take note of the reagents. Potassium hydroxide and then tetraisosulfate 6 acid. So the potassium hydroxide is KOH. Then we're reacting that with what? We're reacting that with tetraisosulfate 6 acid. When an acid reacts to a base, we should know that it will give us a salt, in this case, potassium tetraisosulfate 6, and then water is also formed. To balance this equation, we need a 2 at the back here, because we have 2 potassium here. And then we have 4 hydrogens in total, so I'll place a 2 over here. So I think our equation is balanced now. Now, I've told you from the numerous examples I've been doing that whenever a question gives you the statement, 50 centimeter cube of 1 molar solution, and it's also a 100 centimeter cube of 1 molar solution, the first thing you should do is don't go straight to your stoichiometry. The first of all, use your formula for concentration to calculate the amount in moles. So I'll come down and say let's start off with potassium hydroxide. So for potassium hydroxide, we have that what? Concentration is equal to what? Amount over what? Volume. This is in dm cube. Okay. So if we are to substitute, we are going to have that what? In place of concentration, we have 1. Then our volume is 50 cm cube. So we have 1 is equal to 50. 1 is equal to your amount, n over 50 cm cube, you divide by 1000. So at the end of the day, you have 1 is equal to amount over 0.05. So when you cross multiply, you are going to have that your amount for potassium hydroxide would be equal to 1 times 0.05 moles, which is equal to 0.05 moles. So that's what we have. All right, so after establishing that, we move forward and we do same thing for H2SO4. So for H2SO4, if we make N the subject of formula here, N is equal to N of H2SO4 will be equal to, if you cross multiply, it's going to be concentration times volume. Remember in dm cube. So we're going to have the concentration for the acid is what? 1 mole per dm cube. So we have 1 times your volume. You have 100 centimeter cube. 100 centimeter cube, you divide by 1000, remember? Moles. So that would be 1 multiplying 0.1 moles. So we have 0.1 moles over here. So this gives you the mole of the acid. So this is your first stage. After doing this, we can now go on with the problem. I'm going to take off this part of the board in a minute. Okay, now, since we have gotten the moles we need, we can now go back to this our reaction and say what now? Remember, you make use of your mole ratio. So my mole ratio here, for this we have 2, so for this we have 1. We're just focusing on just these two because the question is only relating potassium hydroxide and H2SO4. So after writing this now, can you please reduce the noise? After writing this, you have, if you have 2 to 1, this is your mole ratio. So the moles that we are actually reacting, for us to understand this, I will need to write them out. So our mole ratio is 2 to 1, right? 2 to 1. So amount, mole before reaction. So the mole we reacted, according to what we've calculated, for potassium hydroxide, we got 0.05. So I will say 0.05 moles. And then for H2SO4, we have 0.1 moles. So I told you, after writing this, you need to determine what your limiting reactant is. How do you do that? You divide this by your molar coefficient. You also divide this by the molar coefficient. The one that produces the smallest result is your limiting reactant. So if you divide this by this, of course, the answer will be smaller than when you divide this by this. So this is my limiting reagent, which is potassium hydroxide. So you come down and say reacting mole, which is the amount that will react. So you always bring down the mole for your limiting reactant, 0.05 moles. Now, from our mole ratio, the mole of H2SO4 that would react is always half of the mole of potassium hydroxide that will react, 1 to 2. So if we're saying 0.05 moles of KOH is reacting, we need to divide this number by 2 to get the mole of H2SO4 that would react. So 0.05, I will divide that by 2. So that gives me 0.025. 0.025 moles. All right. So this is what we need. We don't need all of this. So it means we have some of your H2SO4 remaining. But I don't care about the leftovers. The question did not ask us the amount that is left. The question says calculate the respective volumes while dealing with the amount of the acid and the base that would be required to produce the maximum amount of the salt. So this is the maximum moles that I need for us to get our salt. These are the maximum moles. Now, what does that now imply? I need a board wipe. All right, now we've taken off that part of the board. So we've gotten that these are the moles that I will need for the reaction to take place. So I'll go back to my formula that says what? But remember, concentration is equal to amount over what? Volume in dm cube, remember? So if you make volume the subject of formula, volume is going to be what now? Your amount divided by your concentration. Okay? So we'll come back and say for KOH, we have discovered that the amount for KOH that we need is what now? 0.05 moles. So we have that concentration, volume rather, our volume is going to be, your amount becomes 0.05 all divided by the concentration of KOH is given to be 1 mole per dm cube. So divided by 1. So that is just 0.05 dm cube. Remember, your volume is in dm cube. But then the question said we should calculate in cm cube. So to convert that to cm cube, you multiply that result now by 1,000. So if you multiply by 1,000, you get what? 50 centimeter cube. So this is the volume of potassium hydroxide that would be needed for this reaction to occur. You do the same thing for your H2SO4. So for H2SO4, the volume I would need would be equal to the mole. I've discovered that this is the mole that I would need. So we'll say 0.025. Then you divide it with your what now? Your concentration. The concentration of the acid is also 1. So that also gives me 0.025 dm cube. We also convert that by multiplying by 1,000. So I multiply this number by 1,000 to get my answer in cm cube. So when you do that, that would give you 25 centimeter cube. So this is the volume of this solution that will be needed. So in your exam, your answer becomes 50,25 because the question says respectively. So you mentioned 50 before 25. This gives us the solution to this problem. For this video not to be too long, I'm going to cut it here. If you found this video helpful, please don't forget to like, don't forget to share, don't forget to subscribe to support the growth of the channel. I'm going to see you in my next video. Don't forget, if you have any question on stoichiometry, please drop it in the comment section. I would attend to it. Thanks for watching. Bye.